Hello everyone, in this lecture I will discuss about rolling loads and influence lines. Rolling loads and influence lines. Before going to deal about these rolling loads and influence lines, just we will discuss about static loads. Say for example, if we have a simply supported beam subjecting to a concentrated load W, the beam of length having L. Say for example, it is at a distance of A, and the rest of the distance will be B. Here in this case, we can easily find out the bending moment. How can we find out the maximum, that is maximum bending moment? How can we find out the maximum bending moment? The place where zero shear can occur, at that place maximum bending moment will occur. Say for example, the zero shear can occur at the point of loading, that means here. At this point we can have maximum bending moment. Likewise, we can easily determine the position and intensity of maximum bending moment. Likewise, if we see a concentrated load at center of the beam, say for example the beam of span L, and it is carrying a concentrated load at half of the span, nothing but L by 2 from a point A. Here we can have the zero shear, same as we see earlier, right under the point of loading here. This may be W by 2 and this will also be W by 2. And coming to maximum bending moment, as we said earlier, it can be occurred at the point of zero shear. This is the max bending moment. Like this, we can easily determine and solve the maximum bending moment for the static loads. Coming to here, rolling loads. For the rolling loads will not be stationary at a point. The best example for the rolling loads is the industrial cranes, we can say. Industrial cranes having what is the use of industrial cranes means it can be used for the lifting of the loads, lifting of the heavier loads, and to move from one place to another place within the industry. That is the best example for rolling loads. Say for example, if this is the case, beam A and B having length L, it is subjecting to a load, nothing but subjecting to a load W. Here RA will come and reaction B. These are the reactions RA and RB. And then we need to find out maximum bending moment for this case. Maximum bending moment for this case. So before going to find out the maximum bending moment for this case, we need to draw the influence lines for RA and also RB. So to draw the influence lines for RA and RB, we need to assume an unit load which is applying at both the points. And also we need to assume that unit load which is going to subject at any section from point A. Say for example, I will write here. I will write A and B. This will be RA and RB. If we need to find out influence line for RA and RB, we need to apply an unit load. What is the intensity? What will be the intensity of unit load? This will be 1 kilonewton. Why? Because it is a unit load. So we need to find out we need to draw the influence lines for RA and RB. Okay. Likewise, we can also find out the maximum bending moment. Coming to our subject, our content, we will draw here the influence lines of RA and RB. So, for example, we are applying unit load here. Unit load of 1 kilonewton intensity at a distance of x. The total beam length will be L. Okay. First, we need to find out the reactions for this. So, what will be RA here? Here, RA will be this unit load multiplied by this and total length. 1. A unit load here and multiplied by the length from loading to the opposite support. I am not getting deeper into finding out reactions. Why? Because you are all familiar with this strength of materials in finding out the reactions. I am writing directly here reactions divided by total length. Yes, RA equals to load 1 kilonewton multiplied by length of this distance. That means nothing but load to the distance from load to the opposite support, L minus X whole divided by L. From this we can write. Here we can write L by L minus X by L, that is 1 minus X by L is the RA. And what will be the RB? Same here, load multiplied by distance from the load to the opposite side. We are calculating RB, nothing but we need to consider this distance, nothing but load to the opposite support, that is X divided by total length X by L. So these are the reactions here. We can draw influence line. First we will draw influence line for RA. Okay, influence. If we want to draw the influence line for RA, IL for RA, we need to substitute the X values here. X by L. Substitute the X value here in this RA. First substitute X equals to 0 here. X equals to 0 means this point. X equals to 0. What it will be? I will write here. RA equals to 1 minus X by L. Nothing but 1 minus 0 by L. This will be 1. Oh, 1 minute. Lavanya, stop check. 1 minus X by L. Here we will say, if we substitute 0 here, we will get 1. Here we can draw 1 like this. 1 minute. Yes, 1 we can draw like this 1, and if we substitute X equals to L, R equals to 1 minus L by L. Here we will get 0. This is how we can draw influence line for RA. This is all positive region. Coming to influence line for B, RB equals to X by L. We have the equation right here. We have the equation RB equals to X by L. As this is the beam, RB equals to X by L. First substitute X equals to 0 in this. RB at X equals to 0. 0 by anything, 0. Here 0 it will be 0, and RB at X equals to L. L by L, that is 1. So we can draw like this. This is 1 and this is 0. These are all positive regions. Okay, this is how we can this is influence line for RB. This is how we can draw influence lines for simply supported beam carrying a concentrated load. Next we will see influence line for an overhanging beam.